Right. Good evening today. Let's discuss and continue the lesson that we have done last day. Last day, we were discussing about the block diagram or the logical diagram of the computer and how this computer devices are connected to the computer. Various input devices, output devices, processing devices, and also the storage, communication, how these devices are connected logically. We just explain that using a diagram that is called the block diagram of the system. This is it. You can see input, everything goes through the memory, right? So whatever comes. So for an example, think about this. Currently, what is here in the screen, it is in the memory, right? What is here in the screen, it is in the memory. And the priority will be given based on the activity that we are referring to. So for an example, if we minimize, the memory priority will also be minimized. So let's experiment and see, rather than just like this is a theory lesson, I know, but we can do a small experiment and see how actually it's working. So who can share the screen? Can anybody share the screen? Okay. So this is Tihan's screen. I hope others can see his screen. So shall we open the task manager? You can right click on the Windows icon and select the task manager. Yeah, this is another way. And so let's go to the, okay, now you can see the processors. Click on the memory because we are going to learn about the memory. Click on the memory, yes. You can see the memory allocation. According to Tihan's task manager in his computer, highest amount of memory is now allocated for what? What is the application?
Google Chrome.
Google Chrome. The highest amount of memory is now allocated for Google Chrome. And others, respectively, Zoom is there, WhatsApp is there, you can see. Okay, shall we open another application? I would like if, yes, let's start Illustrator CC. Illustrator, you can see that is in the desktop. When he double click and start Illustrator, okay, you can see the Illustrator is starting. And can you see the Illustrator is coming from the bottom and climbing the ladder? Go to the task manager. And now can you see Illustrator has also taken a portion of memory. Illustrator has also taken now 122 MB. Can you click and show to the others? Okay, 122 megabyte is now allocated from the memory to the Illustrator application. Earlier it was not there. Let's open a new file in Illustrator. Bit small, not a small file, a little large file. Can you start? Open, yeah. Okay. Now go to the memory again. Task manager. Show the task manager again. Uday, can you show the task manager again? Task manager. I know that, right. Now can you see Illustrator has taken 100 Illustrator has already taken 147 MB. Earlier it was 122. Then yeah, 144, 47 maragina. Can you open another one? Shall you open another file? Keep the same file, open another file. Okay, this is another file. Now you can see it has taken 162 megabytes. Okay, what is the conclusion? What is the conclusion? Can anybody tell the conclusion? 162 megabyte is now for Illustrator. What is the conclusion? මොකක්ද අපි ඉගෙන ගත්තේ මේකේ? ඔව්.
When the applications do many tasks by the memory space.
When new application start, it goes to the memory. නේද? මොනවා හරි අලුත් දෙයක් වෙනවා නම් ඒක යන්නේ කොහෙටද? memory එකට. Okay, මොනවා හරි අලුත් දෙයක් වෙනවා නම් ඒක memory එකට තමයි යන්නේ. Okay, let's close Illustrator now. දැන් අපි ඒක close කරමු. Right, when you close the Illustrator, check this task manager again. Now what will happen to the Illustrator? Can you see Illustrator now? දැන් Illustrator පේනවද ඔයාලට? Task manager එකේ කලින් Illustrator තිබුණා. දැන් ඔයාලට පේනවද පුතේ Task manager එකේ Illustrator එක?
නෑ.
නෑ නේද? You cannot see. එතකොට මොකද වුනේ?
memory එකේ
Yes. එතකොට Illustrator දැන් නැද්ද ඔයාගේ computer එකේ? Is it not there or there?
it's there.
Where it is? කොහෙද තියෙන්නේ? Where's the Illustrator? Yes, it is there in the desktop. Actually, what is the device holding that? මොන device එකේද තියෙන්නේ ඔයාගේ Illustrator?
secondary storage.
Secondary storage, simply hard disk නේද? hard disk එකේ තියෙන්නේ. එතකොට run වෙනකොට memory එකට එනවා, අයින් වුණාම අපහු hard එකට යනවා. Okay, this is the behavior. Now try to understand the block diagram. Input devices. When things are running, මොකද වෙන්නේ? When the things are running, that will be loaded to මේ තියෙන hard එකේ තියෙන ඒවා, it will be loaded to main memory and then sent to the processor. When you input something, මොනවා හරි ඔයාලා input කරත්, it will first come to the main memory, then sent to the processor. Before you output something, it comes to the මොනවා හරි දෙයක් පෙන්වන්න කලින් අනිවාර්යයෙන් මේක main memory එකට එනවා. දැන් Illustrator එක අපිට පෙන්වන්න කලින් main memory එකට ආවා. Before output, it comes to the main memory. When it is saved, when you open, it comes to the main memory. When it is input, it goes to the main memory. Actually, when you need to process something, first it will load to the main memory. එතන memory එක තමයි මේ හැම දෙයකම නවාතැන. Everything holds in the memory until it process, until it loads, until it output, when it is input, when it is open, always it is in the memory. That is why memory in the middle. එහෙනම් තමයි memory එක මේකේ මැද්ද තියෙන්නේ. Did you understand that concept?
Yes, sir.
If anything not clear, tell me, then I can explain again, right? මොනවා හරි clear නැත්නම් කියන්න. මම ආයෙ තේරුම් කරලා දෙන්න. මම දැන් practically පෙන්නුවේ ඒ වෙලාවේ කරන දේවල් තියෙන්නේ memory එකේ. And the next important thing is the processor. Whatever said and done will go to the processor. මේක කියලා දුන්නම සමහරලාට ඔයාලට paper එකේ doubt එකක් එන්න පුළුවන්. Right? Sometimes there can be doubt when I teach this, but let's try to understand, because make exam question එකකදී doubt එකක් වෙනවා මම මේක පෙන්නන්නම් ඒ කියලා. I will tell you why this is doubtful in examination question, but you need to learn this accurately. අපි මේක හරියටම ඉගෙන ගන්න ඕන. Okay. So can anybody share the screen again? Can you share the screen again? So let's open MS Word. If you have, let's open MS Word. Okay. Can you load the task manager again? Task manager upload karaganna. Go to the performance. Okay. See the CPU activity. When you open MS Word open කරනකොට මොකද CPU එකට උනේ? Can you see the CPU activity? It went high. ඒක උඩට ගියා. When you open Word, it went high. Open a new file. අලුත් file එකක්, blank document එකක් open කරමු. Open a blank document. Go to the processor and see. Again you can see it's going up. It went up. Okay, start typing something. See the processor. See the processor. Again, it moves up. When you start typing, it moves up. ඒත් ඒක උඩට යනවා. Okay, but we cannot control the other things. That is why anyway, so some other factors are also affecting the processor. සමහර තව factors උත් affect වෙනවානේ process එකට. ඒකෙන් හින්දා තමයි මේ අනිත් තැන් වල process එක නිකන් උඩට යන්නේ. Some other factors are also affecting the processor, but anyway, remember that whatever you do with the computer, it will be treated as a process. Even you input, output, process, even you enter something, type something, print something, everything will be considered as a process. But you know what? In your childhood, so you call water Jo or Bo. පුංචි කාලේ වල වතුරට කියන්නේ සමහර Jo, Bo කියලා. That is not true, but you are telling that. Rather than telling H2O, 2 hydrogens and oxygen, you call it water even. Or one letter word like Bo or Jo. ඒ වගේ තමයි මෙතනත්. Okay, so you can understand why I'm telling like this in the questions. Sometimes in the question paper, they will ask, okay, ICT. Let me search the paper if I, yes, if I can see, I can show it to you. Or you can just go and check 2019, 2020, 2019 papers, or 2021 paper even. Then okay, there is a question. What is so when the processor works? So one answer is when you open a file. The second answer is when you save a file. The third answer is when you type something. Fourth answer is when you calculate the total by adding 2 cells in Excel. Okay. In the examination answer, exam එකේ දීලා තියෙන answer එක තමයි fourth one. When you add 2 things using Excel. ඒක අර straightforward නේ, add කරනවා කියන්නේ process එකක් නේ. But still opening, saving, reading, writing, all are processes. ඇත්තටම ගත්තම ඔක්කොම processes. හැබැයි අර exam එකේ දීලා තියෙන්නේ අර නිකන් එකතු කරනවා කියන එකට තමයි උත්තරේ විදිහට දීලා තියෙන්නේ. But don't worry, that is your nature of the examination. Don't worry much. Okay, now let's move and understand the other components of your computer. Already we have learned the component and how components are working there. So let's understand the physical components. Input devices, I already discussed about the keyboard and mouse. Right, keyboard is having keys. We just discussed about these keys and what these keys are doing. Then the mouse. Mouse can be there in different format. Actually, this is called a pointing device. Pointing device. So what are the pointing devices? Mouse. Anything else? Tracker ball.
Touchpad.
Touchpad.
Lightning pen.
Light pen.
Joystick.
Joystick. And even touch screen. Touch screen is input and output both.
Drawing pen.
Yes, drawing pen. These are stylus. Stylus. These are called pointing device. Why? You can point a place in your screen. Why? Because you can point a place in your screen. ඔයාගේ screen එකේ එක place එකක් point කරලා පෙන්නන්න පුළුවන්. You can point a place in your screen. ඔයාගේ screen එකේ එක තැනක්, එක ස්ථානයක් point කරලා පෙන්නන්න පුළුවන්. Means you can move from pixel to pixel. Using these devices, you can move from pixel to pixel. So what are these pixels? Hari, මොනවාද මේ pixels? What are these pixels? Okay. මොනවාද මේ pixels කියන්නේ? Yes, can anybody tell? What are these pixels? Come on.
An image formed by collecting pixels.
Yeah,
Color.
that is true. හරි, pixel වලින් තමයි image එකක් හැදෙන්නේ. මම අහන්නේ pixel එකක් කියන්නේ මොකක්ද? Yes. What are these pixels? pixel එකක් හැදෙන්නේ කොහොමද? Okay, I will show you a microscopic view of your screen. Can you see? Yes. This is how your screen is visible to a microscope. Let me increase the brightness. Can you see the brightness is now increased? Therefore, you can see the pixels very clearly. Can you see it?
Yes.
Okay. So what is a pixel? What is a pixel?
A color segment.
It is basically a set of LEDs. So this LED is basically there as a set. So 3 colors. What are the colors?
Red, green, blue.
Red, green, blue. Okay. Let's see how these pixels work. Still, you cannot understand what is a pixel very well, but mama taw chuttak explain karanna meka mehem. Okay, I will take a programming language like Python. You don't know about that, don't worry. ඔයාලා ඒක දන්නේ නැත්නම් අපි දන්න එකක් ගමුකෝ. උගල පොඩි කාලේ ඉගෙන ගත්ත එක scratch. You know about this programming language. Let me start. Grade 9 වලදී ඉගෙන ගන්න ඉතින් scratch. Grade 7, 8, 9 නේද ඔක්කොම තිබ්බා. I'll take the pen. And erase all if there are any. And I'm moving the cat just 10 steps. Moving the cat 10 steps means 10 pixels. Pen down and move the cat 10 pixels. Let's make the cat invisible. Like you can make it visible. Let's make it invisible and move it. Now can you see? There is a drawing in my screen in blue color. Small dash. Can you see that?
Yes.
Okay, if I increase this to 100 pixels, you can see it wider. But 10 pixels is narrow, right? Let's make it black color. I just want to change it to black color and then move. Can you see it's only 10 pixels? Let's magnify it. 10 pixels. Let's magnify it. Cannot see anything. Sorry. Cannot control. I cannot control this very well. Okay, now you can control. This is that line, but unfortunately, okay. Can you count the number of bulbs missing? Can you count the number of missing bulbs? Yes.
22.
22. Okay. And I make this little wider. Oh, let's do something like this. I'm going to make it narrow. Oh, still, I'll not be able to see the entire picture. So let's narrow down this. I just want 5 pixels. This is difficult to calculate. It's drawing 5 pixel line. Let's check this now. Okay, can you count the number of missing bulbs now? It's easy, I guess. Number of missing bulbs.
20.
20.
18.
Red bulbs යනවා 1 2 3 4 5 missing bulbs කියන අර කළු පාට එකේ හරිද අඩු bulbs ගන්න රතු bulb අඩුයි 1 2 3 4 5 6ක් අඩුයි නේද 1 2 3 4 5 6 එතකොට අතනින් යනවා green bulbs උත් 6යි blue bulbs උත් 6යි 18 නේ it's 18 right hello
Yes, sir.
it is 18 නේද එතකොට එක පික්සල් එකක් කියන්නේ බල්බ් 3යි. මෙයා ඉස්සරහට යන්නේ පික්සල් 5යි. පික්සල් 5යි කියන්නේ බල්බ් 3ේම 5ක් 15යි. එයා ඉන්න පික්සල් එකත් එක්ක ඉන්න තැනක් ගන්න එපේ. ඉන්න එකත් එක්ක පික්සල් 6යි. 6 pixels means 18 bulbs. So 1 pixel is, what is 1 pixel then? It is RGB unit, right? 1 RGB unit. Understood?
Yes.
එක පික්සල් එකක් කියන්නේ red green blue bulb 3කින් හැදිච්ච එක unit එකක්. තමයි පික්සල් එකක් කියන්නේ. හරි දැන් black color කියන්නේ ඔය bulbs off. Like let's change this color to some other color, right? Like I'm going to change it the color to okay, green maybe. Green. Let's try to draw that and view it. Can you see the view? Sorry, it's not there. Okay. Can you see?
Yes.
Yes, sir.
Now, what are the missing bulbs?
Red and
Red and blue.
blue.
Red, blue bulbs are missing, but green bulbs are visible because the color is green, right? Can you
Yes.
understand how colors are made in the screen?
Yes, sir.
By turning on and turning off bulbs. මේ bulbs on off කළා තමයි මේ screen එකේ colors පෙන්වන්නේ. දැන් අපිට පෙන්වන්නේ ඔන්න green bulb එකක්. අපි මේකට yellow දැම්මොත් if I put this yellow, what will happen? Put yellow. Try this again. See the view. Can you see? What are the colors visible?
Red and
Red
green.
and green.
Red, green. Red, green will create yellow color.
Yeah.
Understood how colors are made?
Yes.
If I reduce the intensity, brightness එක අඩු කරොත් what will happen? These colors will slowly reduce these bulbs will slowly stop the luminosity or reduce the luminosity. දීප්තිය අඩු කරනවා නේද bulbs මම බලේ අඩු කරන්න බලන්න. bulbs වල දීප්තිය අඩු මෙහෙම වැඩි කරද්දි bulbs වල දීප්තිය වැඩි. තේරෙනවද පාටවල bright වෙන්නේ කොහොමද light වෙන්නේ dark වෙන්නේ all these things can you understand?
Yes, sir.
This is intensity, right? Intensity of the bulbs. හරි ඔහොම තමයි ඔක වෙන්නේ. This is how practically this is happening, right? Even though this is a theoretical lesson, yes, if you really like to learn, you can learn like this. හැබැයි මෙහෙම උගන්නන්න ගියොත් මට ප්‍රශ්නේ තියෙන්නේ මෙයාලා O level ICT කරන්න නැතුව ඔයාලට practical කියලා දීදී ඉන්න වෙනවා සෑහෙන කාලයක්. එහෙමත් කැමති නෑනේ ළමයින්ට ඕන විභාගෙ ලියන්නනේ. මම නම් කැමති ඉතින් ඔය අතිරේක දේවල් උගන්නලා ඇත්ත උගන්නන්න. But the main thing is rather than learning the truth, most of you guys need to write the examination paper. Because I have experienced that. මොකද මම දැන් මෙහෙම කළා අමාරුවෙන් ඔන්න O level A එක කොහොමත් ඔයාලට ගන්න පුළුවන්. You will get O level A pass easily, but the difficult one is get the IT passion. So after creating passionate IT students, their teachers are advising them to do you are maths karanna, you do biology, you do maths because you have good result, you have 9 A's, do maths, or you have 9 A's, do biology. So then my kids are asking, can we do ICT because we are passionate, we really like ICT. අයියෝ ICT නොවුන්නේ ICT කරාම වල engineering යන්න බෑ ඔයාලා. එහෙම කරන්න එපා ඉන්න maths ම කරන්න. So this is what the teachers are advising. They are advising our kids to do mathematics and or biology rather than doing ICT. But that is wrong. Right? I am a live proof for that. Why? I am a registered member of the Institute of Electrical and Electronic Engineers. If IT is not an engineering subject, I cannot register there. IEEE is the largest organization of engineers, the world's largest engineering society. That is IEEE. The world's largest technical professional organization for engineers. So as an IT engineer, I am registered with IEEE. But in Sri Lankan context, there's a myth telling only maths students can go to engineering faculty, others are not. That is not the truth. Actually, we are not a STEM country even. We are not a STEM country even. So don't bother much about what people telling in Sri Lanka. So what are the STEM? STEM means science, technology, engineering, mathematics. See, we are not a STEM country, right? So STEM ranking countries, if you check STEM country ranking, අපේ රට ළඟපාතවත් නෑ මේ STEM ranking වල. ඒ හින්දා අපේ රටේ engineering කියන එක ගැන මහා ලොකුට හිතන්න යන්න එපා ඒගොල්ලෝ කියන comments. Because actually most of these people don't know what engineering is. So let me show the country ranking properly with a map. Here you can see we are not even the first 100. මුල් 100වත් අපි නෑ. This is 2018. China, Singapore, Estonia, Japan, South Korea, Canada. These are the STEM countries. These are the countries use STEM much. Science, technology, engineering, mathematics. Even though we have large audience doing maths, A-level maths, A-level science, but still we are not a practical STEM country because we are not applying. We have knowledge. Our kids are knowledgeable, but unfortunately, those kids are not practical. Most of them. They are knowledgeable, or they are not practical. They are not in the international level. So don't believe what they say. Right? Even I have to tell this because මොකද මට දැන් මේක වෙලා තියෙනවා. මම පොඩ ළමයි මේවා කරගන්නවා train කරලා IT passionate ළමයි හොඳ student set එකක් හදාගන්න මට පුළුවන්. මේ A level ICT වලට හොඳ දෙයක් කරන්න පුළුවන්. Practically දෙයක් කරන්න පුළුවන් වගේම ලංකාවේ හොඳ result එකක් ගන්න පුළුවන්. But අපේ teachers like තුල ඒ ඔක්කොම ළමයි ටික දානවා maths වලට හරි මොනකට හරි. Even though they are passionate in ICT, ultimately they will not do ICT. This has happened to me several times. So I am really disappointed of what they are doing. That is not good. Because they think that ICT is a subject which is coming after maths, after science. ICT is the number one subject in the world. Why? You can say the top 10 richest people in the world. That is easy. Top 10 richest people in the world. So if you analyze, then this is in 2018. You can see Jeff Bezos, Amazon, Bill Gates. That is Bill Gates is Microsoft. Then Mark Zuckerberg, Facebook, Larry Page, Google, Larry Ellison, Google, Sergey Brin. You can see these people, and this is another year, top 10. Elon Musk, Tesla, ICT, Jeff Bezos, Amazon, Bill Gates, ICT, and Larry Page, Larry Ellison, Google, Sergey Brin, and this Larry Ellison, Sergey Brin, and then so one is from Oracle. Sorry, this is from Oracle, right? Likewise, even they are telling it is number one. Yes, maths is number one, but it is not that engineering that they mean. The ICT engineering or ICT is the number one in the world now. So even though in Sri Lanka we have given a very less priority, this practical subject is rocking, right? Therefore, learn carefully and you can become one of them one day and tell me that, yes, we have achieved the goal. So just share your success story one day. Okay, anyway, pointing devices. We learned that what these pointing devices are. We can move from pixel to pixel. We learn what is pixel as well, right? Now I think I don't want to discuss much about these devices, as you know. Any doubt? මේ pointing devices ගැන doubt එකක් තියෙනවද මොන හරි pointing device කියන්නේ මේ pixel වලට access කරන්න පුළුවන් device. You can move from one pixel to another pixel. Mouse එකෙන් පුළුවන්, keyboard එකෙන් අමාරුයි නේ pixel එකෙන් pixel එකකට යන්න. But using mouse it is possible. Using tracker ball it is possible. Tracker ball කියන්නේ mouse එක අනිත් පැත්ත හැරුවා මෙන්න එක. මෙන්න මේ වගේ. joystick එක වගේම තමයි tracker ball එක මෙතන නැහැ. Here this one. Tracker ball is basically the reverse mouse. There is a ball and two buttons, and this ball is basically ball you can rotate. So you don't want to move the mouse here and there. The mouse එක තිබ්බොත් අරහෙට මෙහෙට අරන් යන්න එපා. Ball එක තිබ්බොත් ball එක කරකවන්න විතරයි තියෙන්නේ. You can put it in one place and rotate. You can place it in one place and rotate. That is the advantage. එක තැනක තියලා මේක rotate කරන්න පුළුවන්. හැබැයි අර විදිහට මේ මොකද්ද? If it is a mouse, you need to move it here and there. It needs space. The tracker ball එකට space එක අඩු වෙනවා. It's kind of a joystick. Joystick වගේ තමයි ටිකක්. Okay, light pen. Light pen ගොඩාක්ම පාවිච්චි කරන්නේ මේ screen එකේ අඳින්න. Screen drawing. ඔය ඉස්සර cricket match එකම තියෙද්දි මේක පාවිච්චි කරා. Earlier days when there was cricket matches, in the commentary, they have used this. Commentary ke kiyana me man දැන් කරන්නේ light pen වගේ තමයි. Using zoom also I'm drawing. Commentary ke kiyana meta there are two fielders here. You can just place the ball here, then you can achieve a boundary easily. So this is a gap. Likewise, they are showing. So that is using the light pen. Similar drawing like this. Joystick, there are different joystick, even steering wheel kind of joysticks are there. Have you seen this? We have one in STEAM school, our STEAM school. Steering wheel and full set of joysticks are there. Full set steering wheel, clutch, brake, accelerator. This is a joystick. Make a joystick. Steering wheel, like a clutch, like a brake, like a accelerator, like all these things are. This is a joystick. There are joystick for autopilot systems. Right. This joysticks is there. Joystick system is there for autopilot systems and some systems, some virtual pilot systems. Joysticks are there. Driving joysticks are there. Game here, this one, you can see joysticks. Steering and joysticks. So that is also a pointing device. And some are missing. Light pen, stylus. Smart board. Smart board is IQ board. Do you know IQ board? Do you know IQ board?
No, sir.
ඒවා schools වලට දීලා තියෙනවා. IQ board කියනවා නැත්නම් smart board කියලා කියනවා. මේකේ basically it's a surface device. Basically you can do, it's like a digital screen where you can touch and do various things, and there are applications also like this. There are different applications that you can, this is a very large skin, it's like a whiteboard. Whiteboard එකක් වගේ ලොකු එකක්. මේකේ අර tools තියෙනවා. ඔය අඳින්න drawing වලට rulers අරම ඒවා තියෙනවා. Chemical related ඒ වගේ තියෙනවා. ගොඩක් සමහර apps පාවිච්චි කරන්න පුළුවන්. project එකටත් මේකට focus කරලා use කරන්න පුළුවන්. This is an interactive board. This is an interactive board. There are in schools, there are IQ boards. Smart boards may school වල තියෙනවා මේවා. Right? This is like a touch screen, right? But actually this is not a screen. This is by focusing. අතර මේ project එකක් මේකට focus කරලා තමයි මේ හදලා තියෙන්නේ. Right, here you can see there is a projector, and this projector is focused to this board. That is how the smart board is made. Okay. Right, in some schools මේවා තියෙනවා. දැන් ඉස්කෝලවල කලුතෙන් ඇවිල්ලා තියෙන ගොඩක් ඒවා. ටිකක් ගණන් ඒ හින්දා සමහර විට නැති වෙන්න පුළුවන්. ඒ වුණාට මේක දැන් අවුරුදු ගාණක් ඇවිල්ලා. හරි. Okay. Next is touchscreen. You already know. Touchpad, you know. Sometimes in some keyboards joysticks are there, right? Within the keyboard joystick තියෙන්න පුළුවන්. සමහර lap වල එහෙම මම දැකලා තියෙනවා. එහෙම තියෙනවා. keyboard එක අස්සේ joystick එකක් දාලා තියෙනවා. මෙන්න මේ වගේ. Yes, you can see something like this. Within the keyboard joystick can be there, or something like this. Something like this can even be there. Within keyboard joystick can be there. Keyboard embedded joystick. Oh, it should be other way. හරි මේ joystick එකට keyboard එකක් හයි කළා. ඔගේ අනිත් පැත්ත joystick embedded keyboard. ඔය දෙපැත්තටම තියෙනවා, right? Joystick embedded keyboard. In a keyboard you can see, within the keyboard you can see small joystick. In laptops this sometimes this can be seen. සමහර laptop වල මෙහෙම තියෙනවා. keyboard එකේ මැද්දේ මෙන්න මේ වගේ. This is called pointing stick. Pointing stick or joystick. Within the keyboard sometimes you can see this here. Okay, sometimes pointing stick or joystick. Okay, here you can see another one. Okay, in a keyboard, basically there are two special keys, that is J key and F key. Can you see in this keyboard also? ඔයාලගේ keyboard එකෙත් බලන්න. These F and J key are special. Why? This F key and J key are special. You can see here also. ඒ දෙක අතට දැනෙනවා. If you close your eyes and touch them, you can feel here there's a small part here and here. This is where you place your index fingers in touch typing. ඔයාලගේ keyboard එක S2 වහගෙන type කරන එකට අපි කියන්නේ S2 වහගෙන නෙමෙයි අතන. keyboard එක දිහා බලන්න නැතුව type කරන එකට අපි කියනවා touch typing කියලා. Without looking at the keyboard, if you type, that is called touch typing. keyboard එක දිහා බලන්නේ නැහැ, screen එක දිහා විතරයි බලන්නේ. එතකොට S2 වහගෙන මේ key දෙක ඇල්ලුවම අපිට දැනෙනවා. අපි සාමාන්‍යයෙන් index fingers දෙක අපේ දබර ඇඟිලි දෙක ඔය keys දෙකේ උඩ තියෙනවා. F and J. We place these keys. That is why there are two small lines in this, because to touch and feel. එතකොට මෙතන ඉඳන් තමයි මේ index finger එක T අකුරට යන්නේ, මේ අකුරට යන්නේ, V අකුරට එන්නේ, R අකුරට යන්නේ. index finger එකම තමයි මෙතන ඉඳන් ගිහිල්ලා ආපහු මේකටම එනවා. මේ අනිත් index finger එක මේවට ගිහිල්ලා ආපහු එතනටම එනවා. Move and come back. That is how the index fingers work. Right? That is, for the touch typing, you can see there are two small parts in the keyboard also. So, okay, let's move to the next part. So, I personally said, I don't like this. Why? This is not true. This is utter foolish thing. I don't know why they have added this. They are responsible, but they have done something irresponsible. This is wrong. මේක ඕන බබෙකුට තේරෙනවා මේක වැරදි. ඇයි? මේක input ද? Is it an input device? Is it video input device? Is it image input device? එතකොට මේ screen එකට මොකද කරන්නේ? මේකේ තියෙන screen එකට මොනවද කියන්නේ? ඒ ගලව line කරනවද? Are we going to remove that? එතකොට මේකේ memory card එකක් තියෙනවා storage වලට. So what we are going to do with that? There is a processor also inside this. What we are going to do with that? This has input, output, storage, processor, and there's a memory also. Actually, this is a small embedded computer. මේ තියෙන embedded computer එකක්, small embedded computer. This is not true. This is not input device. Digital camera, ඔයාලා exam එකේ දුන්නම ගහන්න උත්තරේ. ඒ වුණාට in your exam you can mark this, but this is not true, right? Webcam is true. Webcam ගන්න පුළුවන්. But digital camera is a separate device. It has a system, input, output, process, everything is there. Okay. Webcam is input, yes. CCTV is input. CCTV cameras, right? CCTV කියලා ගන්නත් බෑ. CCTV cameras. මොකද CCTV වල තියෙන DVR. DVR is having processing, storage, everything. LCD monitor ඔක්කොම තියෙනවා. But closed circuit television cameras, CCTV cameras are inputs. Scanners, flatbed and handheld. Yes. And there are several set of scanners. I said that I will be discussing this, but unfortunately today I had to take some time to explain the previous lessons. But there are a lot of scanners. So let's learn about the scanners. Right. Write down as a heading, write down scanner types. Scanner type. Scanner varga. මොනවද scanner varga වලට තියෙන? Flatbed scanner. Keep on top of a desk and scan. Normal computer scanner is a type of flatbed, right? Flatbed කියන්නේ මේ computer desk එකක් උඩ තියලා scan කරන්න තියෙන scanners. සාමාන්‍ය scanners කියන්නේ සාමාන්‍ය scanners ගැන තමයි කියන්නේ flatbed කියලා නමක් දාලා. Scanners mainly scanners. Handheld scanners, these are special, portable. Handheld, portable, movable scanners. We use this for අපි use කරන සාමාන්‍යයෙන් barcode scan කරන්න, QR code scan කරන්න. infrared scan කරන්න. infrared scanning අර උණ එහෙම බලන්න. ඒ වගේ දේවල් වලට අපි use කරන ultrasound scanners. හරි ඔය වගේ දේවල් වලට අපි handheld නෙමෙයි held as sorry handheld scanners use කරනවා. flat bed handheld. Handheld is a single word, sorry. Flat bed handheld. And there are many. තව තියෙනවා. One is OMR. The second one is MICR. Then USR. MSR. MRI. CAT. PET. X-ray. There are many. And there are something called OCRs. OCR. හරි මේ ටික කියන්න බලන්න OMR. What is OMR? What is OMR scan? OMR කියන්නේ මොකද්ද? හරි. Okay, I'll do something. So I will give you 2 minutes. Can you find out the answers and send it to the chat? නිකන් මටත් කම්මැලි නැත්තම්. OMR to OCR. Find out the abbreviations, send it to the chat quickly. Within 2 minutes, right? Within 2 minutes, quickly. OMR, optical mark reader. Normally, this is used for optical mark reader, right? This is used for paper marking. Optical mark recognition, optical mark reader, used for paper marking. Have you seen that some papers you are asked to color the balls? Like, so you are given MCQ answers like this 1, 2, 3, 4, 5, and again 1, 2, 3, 4, 5, and you need to mark the correct answer. When you're marking the correct answer, you have to color the answer. So likewise this, the first one is the answer, fourth one is the answer. Likewise in the MCQ paper, multiple choice question paper, you have to color the answers. In this case, in this situation, OMR is used to mark the paper. Paper marking වලට තමයි මේක use කරන්නේ. ඒතර automatically දැන් A level paper එක O level paper එක mark කරන්නේ මේ OMR machines. Actually, answers are fed into the machine. That's why they are asking to not to erase this and not to use erasing ink, Tipex. The reason is then they cannot identify, the machine cannot identify and properly color the balls, shade it. That is optical mark reader. Special scanner, MICR, magnetic ink character reader. For check reading, for check deposit, check reading, we are using MICR. Checks. Payment check, deposit karadi use karno, MICR. Ultra sound scanner. This is a medical scanner. It's a medical scanner. Magnetic stripe reader. ATM card වල එහෙම පිටිපස්සේ තියෙන්නේ. Back of the ATM card there is a black color magnetic stripe. To read that, this ATM machines use MSR. ATM machines can use MRI, magnetic resource imaging, MRI. That is also a medical scanner, magnetic resource imaging. CAT, computer axial tomography. That is also a medical scanner, computer axial tomography. So here, this is the one. CAT scanner, computer axial tomography. The brain scan, brain imaging and all, this is specially used. And the PET scanner is also a scanner. Right? PET scanner is also a scanning machine, similar to the CAT scan, but specially to identify. Here, the CT scan is another one. Right? That is called positron emission tomography. PET, positron emission tomography, and CT scanner also. CT scanner. CT scanner is also somewhat similar, right? Which is the meaning is basically computerized tomography, computer axial tomography or computerized tomography, computer axial tomography, computerized tomography. So both are the tomographic scanners. CT scanner, computerized tomography, X-ray, and this is computerized tomography. So a lot of medical scanners are there. X-ray scanner, that is, X-ray is X-ray. Right? OCR, optical character recognition. So this is actually a software which can be used with a scanner. Some are like scanner, some scanner itself, OCR scanners can be there, but it is actually software. Right? Rather than a tool, it is a software. This software can identify the letters, right? Have you used Google Lens? Have you used Google Lens?
Yes, sir.
Google Lens can
Yes.
identify the character. Any language can be translated live. නේද වෙන language එකකින් තියෙන එකක් ඒ වෙලාවෙම translate කරන්න පුළුවන් වෙන භාෂාවකින් තියෙන එකක් Google Lens දාගෙන බලන්න ෆෝන් එකට ඒ app එක දාගන්න පුළුවන් Google Lens app it can translate any language within a fraction of a second, right? So even this node you can translate very quickly. This node, if you need to translate, you can use a simple this one. It's a very simple one. Let me send image to your group also, and I'm using I'm going to use lens here. When I read this node using the lens, when I read this node using the lens, I can go to the translate option and translate this to Sinhala. Okay, just for your reference, I'm sending this, right? I'm sending this just for your reference. Right. Okay, I can share this. I'll share this to the WhatsApp group that you are in. But please understand, this is only not as a note. Make a note විදියට නෙමෙයි මම මේ share කරන්නේ. I'm sharing this just to give you some idea how this okay, I have shared this to the WhatsApp just to give you some idea on how this can be used. Okay. So here it is. I have sent this and you can just refer to that. Can you see? Okay. Right. This is actually I have taken for even it has translated my MacBook Air there. I got translate karla, and you can see here. ඔබ තිරේ බෙදා ගනිමින් සිටීමේ උඩේවත් උදව් කවුළු ඔක්කොම translate කරලා. The entire screen has translated. මුද්දර මොනවද මේකේ කියලා දාලා තියෙන්නේ. The entire screen is translated. You can see. That's it, right? So this is using Google Lens. Okay, with that I will conclude the lesson for today, and I will discuss the remaining part next day. So please take a screenshot of that and later write down. Okay, good night. See you all next week.
Good night, sir.
Good night, sir. Thank you.
Good night.